Hello, I welcome you all for a brief video presentation on the topic permutations. I am Bharath, belonging to 4th semester CSE Artificial Intelligence Department at Sri Venkateswara College of Engineering, Bangalore. Here, the subject which I'll be going through in this presentation is discrete mathematical structures, and we will be looking at the topic permutations. First, let us see, let us introduce ourselves to permutations. Let us look on what is the definition of permutation. Permutation are the arrangements of objects in a specific order. In mathematics, permutations are used to calculate the number of ways in which a set of items can be arranged. This is what the permutations are defined as. Importance in mathematics and real-world applications. Permutations play a crucial role in various mathematical concepts such as combinatorics and probability. They're also used in real-world applications such as cryptography, where data encryption relies on permutations to ensure security. This is about the topic. This is how it is defined, the permutations. Next, let us look on a few basic concepts of permutation. First thing, let us see what is the difference in permutations versus combination. Permutations involve arranging items in a specific order, while combinations are selection of items without considering the order. This is the main difference between a permutation and combination. Next, let us see about factorials. Factorials are the product of all positive integers up to a given number. For example, 5, which is read as factorial of 5, equals to 5 multiplied by these numbers, leading to 120. Now, let us look at the next slide. What is the general formula for permutations? Here, the general formula P of nr equals n factorial into n minus r factorial. P of nr equals by factorial n minus r factorial into n factorial. Here, n and n is the number of total items, r is the number of items to be arranged, n factorial denotes the factorial of n, which is the product of all positive integers up to n. N minus r factorial is the factorial of the value which we get by subtracting r from n. What's the explanation of this? It is the formula calculates the number of ways to arrange r items out of a total of n items, where the order of arrangement matters. Next thing, let us look at some examples for simple permutations. The below are two examples. First one is about arranging 3 out of 5 books on a shelf. So by applying the formula, which is P of n comma r, we get the final answer as 60 ways. Let me point it out for you. Final as 60 ways is what we get by working out on this P of 5 comma 3 formula. This is for arranging 3 out of 5 books on a shelf. Next thing, the second example we will look on arranging the letters in the word cat, that is P of 3 comma 3, because the word cat has only 3 letters in it. So we are taking both n and r values as 3. When using P of 3 comma 3 and the formula, we get a total number of 6 ways, which is also we get by taking the factorial of number 3, because we have to arrange all the letters of that word. Next, let us see some special cases. Permutations of all items. N equals r. When all items are arranged, that is P of n comma n equals n factorial into probability of n comma n equals n factorial equals n factorial. This simplifies the formula to the factorial of total number of items. Fine, just as we did for cat. Because there were only 3 letters in the cat. So what we did was, instead of putting the P of n comma n formula, we just took it as 3 factorial. Even if we put the p of n comma n factorial formula, the final answer would be 6. And if we take it as 3 factorial directly, again we would reach to the same place. The final answer would be 6. Because the value of 3 factorial is 3 into 2 into 1, which is 6. 3 2s are 6 and 6 1s is 6. This simplifies the formula to the factorial of the total number of items. What are the total number of items? For that, the formula has been simplified. Permutations of distinct items. Permutations of distinct items involve arranging items where each item is unique. Permutations of distinct item involves arranging items where each item is unique. In this case, the number of permutations is simply n factorial, where n is the number of distinct items. Number of permutations is, in simple terms, it's n factorial. As we were speaking about this word cat, all items are distinct in the word cat. Here, we can take it as n factorial. What is the n factorial? Cat has 3 letters. N factorial, 3 factorial is equal to 6. This was a special case of permutation. Circular permutation. This occurs when items are arranged in a circle and the order matters. Here, there is a certain order to be followed after each item. Which item has to come after which item? This order of precedence will be followed during circular permutation. Rotations of the same arrangement are considered identical. Okay, a rotation of the same arrangement are considered as identical. You cannot do this. So circular permutations have a slightly different formula. For circular permutations, the number of arrangements is given by n minus 1 factorial, where n is the total number of items. Example, arranging 4 people around a table gives you 4 minus 1 factorial, that is 3 factorial is equal to 6 unique arrangements. Fine. So we have a round table. There are 4 people in the table. What we are doing is we have to arrange those 4 peoples around the table in such a way that they do not sit in the same identical pattern. So this thing can be done in 4 minus 1 factorial as per the formula. Here it is n minus 1 factorial. In this way, we can take it as 4 minus 1 factorial, which is 3 factorial. What is 3 factorial? As we spoke earlier, 3 factorial is 6. Next, let us look on permutations with repetition. Permutation with repetition occur when there are repeated items in the set to be arranged. In a set, there are more than one item of the same kind. At this time, the permutation with repetition is given. Permutation with repetition has its own unique formula, which is shown here. Let us look at an example. For the word Mississippi, there are 11 letters with repetitions. Here, Mississippi has total 11 letters, but all 11 letters are not unique. They are different in each. Here, see, we don't have unique 11 different letters. What we have is we have 4 S, 4 I, and 2 P's. Fine. There are 4 letters of S, 4 letters of I, and 2 letters of P. So the number of permutations is, what is the total? There are 11 letters, so 11 factorial multiplied by number of S, that is 4 factorial, number of I, that is 4, so it's 4 factorial, and 2 factorial for the 2 numbers of P's. So by this formula, we can find out the final answer for permutations with repetition. Applications in mathematics. Where is permutation used in mathematics? It is used for solving equations. Permutations are used to calculate the number of ways equations can be arranged or solved, particularly in combinatorial problems. Probability and statistics is also another place where, in mathematics, where permutations are used. Here, permutations play a key role in calculating probabilities and determining the number of outcomes in statistical analysis. Let us look at two quick examples. That is, calculating the number of ways a committee can be formed from a group of people. This is also a question. Suppose you have 5 members. You need to calculate the total number of ways a committee can be formed by a group of 5 members. I'm here. There are 4 more with me. Total out of these 5, in how many ways a committee can be formed? And another example is determining the number of ways to arrange a deck of cards. How many? There are 52 cards in a deck. Deck of cards means the total number is 52 cards. Here you can use permutations also. And if you're taking it as color based, number based, or card based, then you can use permutations with repetitions. In both the types, you can find the number of ways you can arrange those cards in a card deck of 52 cards. This is how the permutations is applied in mathematics. Now let us even see about applications in real life, where permutation is applied in real life scenario. In day-to-day life, how do we use permutation? Seating arrangements. Permutations are used to determine the number of ways people can be seated at a table or in a row, where the order matters. Where the order matters, you can use permutations formulas to determine in how many number of ways the people can be seated in a table, like how we saw 4-member table, or in a long row. Password generation is also there. Permutations are used in generating unique passwords, ensuring security by creating different arrangements of characters. It is used for scheduling. Permutations help in scheduling tasks or events, ensuring efficient arrangement based on priorities and constraints. Let us look at two examples. First one, determining the seating arrangements at events or conferences. When you go to an event, when you go to a conference, you can determine what kind of seating arrangements can be used. Another thing is generating unique and secure passwords for online accounts. This is also another application of the permutations. And all these permutation applications are used in real life. Now let us look as a AI engineer or from a computer science background, where permutations can be used in computer science. First thing, we can use it in an algorithm design. Like they can be used for designing certain based algorithms for sorting, if you want to sort those numbers, or if you're searching for some element within an array or within a list. And this is used for some optimization problems. What they do is they help in generating different arrangements of elements and different types of arrangement of elements to find the most efficient solution among them. Fine. And one more thing, it is used in data organization. These permutations are used to organize data in a specific order for efficient processing. How do you process this efficiently? For this, you can use permutations to find a specific order. And they even play a crucial role in data manipulation and retrieval. Permutations always does in data manipulation, because you're going to keep on switching the elements every now and then. And for retrieval also, there are some softwares which hack passwords, if you know. It keeps on generating passwords until the real match is found. And that way it is done. Example, permutation and sorting algorithms like bubble sort and quick sort. Let us not go deeper into these sorting algorithms because they do not belong to permutations directly. Permutations is used there, but sorting is not belonging to permutation. Permutations in generating unique identifiers or keys in databases. Like how I said, for passwords, what they do, multiple number of permutations is used to find a password matching. So here is to generate identifiers, because so many if you're generating, you can generate a very unique identifier. Permutations are used in generating passwords also. So if it is used for generating password, it means it is very unique. This permutation is used in unique identifier or keys in databases. And the next thing, permutations in cryptography. Encryption techniques. Permutations are used in encryption algorithms to rearrange data, making it unreadable, without the correct decryption key. Encryption, opposite is decryption. Permutation cipher, a type of encryption. Permutation cipher is a type of encryption where the positions of characters in a message are rearranged according to a predetermined permutation. Fine. The next one is about key generation. Permutations are used in generating encryption keys for such works, and this ensures that each key is unique and secure. What is encryption key? It won't be wrong if you tell that the encryption keys can also be called as passwords. Encryption means, suppose we get a notification in WhatsApp telling the chats are end-to-end encrypted, which means the sender and receiver can see it, no one else. And if someone else has to access that encryption, they need to give a specific key for that. This encryption key is there. For this, permutation is used because it makes it difficult to be read. Then permutation cipher, a type of encryption where the position of characters is a message, Example, using permutation to encrypt a message where the order of characters is rearranged based on a specific permutation. This can be found in cryptography. Cryptography is not a small thing. It is all for trading. So they require very strong passwords, and these can be done with the help of permutations in computer science application. There's also cryptography, making these key generations, permutation ciphers, encryption techniques. All these are, different kinds of applications of computer science itself. Application of permutations in computer science. The next thing is problem-solving techniques. And what techniques a problem can be solved using permutation? First one, it's a step-by-step approach. Like you have to understand the problem statement, identify the total number of items and the number of items to be arranged, determine if repetition is allowed, whether a repetition is allowed in solving this problem. If not, you cannot use permutation. Apply the permutation formula to get to the final answer. Common mistakes to avoid here. Yes, you cannot be 100% correct every time. You do make mistakes. And commonly, mostly made mistakes are those which you can pick it up so that in the end you can make a report on that. If you can analyze the most number of mistakes, you can find a lot of mistakes which is done in common. You have to avoid those common mistakes to improve your efficiency. What are the common mistakes in permutations? First thing, forgetting to use the factorial notation. When you're using the factorial notation, after a number, you're going to put an exclamation. If you're multiplying also after a number, you're going to put another exclamation. If you're forgetting to use that exclamation mark, it is read as a number, not as a factorial. And misinterpreting the order of arrangements. Interpretation is very important because again and again, if you're doing this manually, you're ordering it something, next order, next order, next order. By the time you go down, if you forget something which you have ordered above, and if you're not interpreting it properly, you're going to repeat those values again. And at times when repetitions is applicable, you have to consider those if it's applicable. And neglecting to consider repetitions even if applicable is also a common mistake. You might feel that permutation means it cannot be repeated, but at times you have to repeat it. You got to repeat permutations. And let us look at an example problem. Arranging 3 out of 5 books on a shelf without a repetition. A simple problem. There are 5 books. You're keeping 3 of those books, any 3, on a shelf, but you should not repeat the order of the arrangements of the book. How do you do this? This is done using permutation. Next, there are some practice problems which there is no need to go. You may try this if you want. There are 2 or 4 problems over here. What are the benefits is reinforces understanding of permutation concepts, builds confidence in solving permutation problems. How confidence is built? Because you're solving the 4 problems, solve it, the confidence builds up automatically. And how do you visualize permutations? There are multiple ways of visualizing things. The whole concept is based on visualization. Tree diagrams, or you have an example problem also to be done. And this include a sample tree diagram for illustration of permutation scenario. What happens is using a tree diagram, it provides a clear and structured visualization of permutation scenarios. This helps in understanding and solving complex permutation problems. This is about visualizing it. Permutation puzzles, they're there. Puzzles can be made on permutations because it's possible. Puzzles are all of these type only. So permutation puzzles are possible. Then historic background, early mathematicians. Let's just look into some of the history of permutation. Leonhard Euler, Carl Friedrich Gauss, and others studied permutations, and they have made significant contributions to the field of mathematics. Evolution of permutation theory. Permutation theory was evolved over time. Early applications to use modern uses in various fields. And about relevance, permutation have been used throughout history to solve problems. Understanding the historical context helps appreciate the significance of permutations in mathematics. This is about the background of permutations, which is not necessary, but it's better to just know about the history when we are reading something. Next thing, there are a few advanced topics in permutations. Permutation groups. This describes symmetries, set of objects in the permutation, important in group theory, branch of abstract algebra, many such things. Cycle notation used to represent permutations as compactly, understanding the structure of permutation, permutation matrices, matrices that represent permutations useful in linear algebra and computer science. And applications, studying symmetry, group action and classifying mathematical objects. This is some of the advanced topics of permutations. Now, before we finish this, let us look on to summary. Permutations are arrangement of objects in a specific order. This is used in mathematics and various real-world applications. Then the formulas are there. What are the applications in mathematics, like solving equations, probabilities, and statistics? In real life, arranging the seating arrangements, password generation, and scheduling. This is also used for problem solving. That is a step-by-step approach. Understand, identify, determine, and apply. Common mistakes also we saw, which we have to avoid in permutations, which is factorial notation. That is not forgetting to put that factorial notation, which is that exclamation mark, order, and repetition. Conclusion is that permutations are fundamental in mathematics and have practical applications in various fields. Wherever you go, you have the application of permutations. This was about permutations. Stay tuned. See you soon in the next video. Thank you very much for being through the video. See you soon. Thank you.